All right, so in this lesson, we're going to talk about how to write an exponential function if we've been given a graph, a table, or words. So we're going to start out with this graph. And what I'm going to do is define some of the points on here. And I'm going to use points that are actually on tick marks. So if we look at our x and y values, this point is -4, -4. We have -3, -2, -2, -1. So I can see my pattern here is multiplying by a half and a half again. So if I was at -1, half of this would be -1/2. And then at 0, because I'm going to try to write a function, so I want to know my y-intercept, this would be -1/4, because 1/2, oops, I put the answer here instead of the ratio. 1/2 times 1/2 gives me 1/4. So I'm going to use this as my starting term. And remember, my output is the first thing I write. So it's -1/4 multiplied by our pattern of 1/2. And the exponent is just x because this is at term 0. Your negative sign is never going to be in your pattern when we're dealing with these exponential functions. Our negative sign is always going to be out front with our coefficient. So that's how I would go about writing a function from a graph. I want to find my y-intercept. I'm going to use that output as my coefficient. I'm going to use the pattern inside of the parentheses, and then if I'm using my y-intercept, x will be my exponent. All right, so next we have a table. And one thing that I notice is that this jump in x is not +1. I'm going up by 2. So there is a missing term here in the middle. So one thing that might be beneficial is to rewrite this as a new table and put in all of the x values we're going to need. So -1, 0, 1, 2, 3. And then figure out these missing pieces. So this is 12, this is 3. Now I'm going to rewrite this as 3/4. And that's only because it helps my brain personally to see this as fractions instead of decimals. So this big jump from -1 for x to 1, well, 3 is 1/4 of 12. So if I multiply by 1/4, I would get 3. Now, in order to do that in 2 jumps, I need to do, now this is where you got to put on your thinking cap. I have to figure out what 2 things multiplied together that are the same would get me 1/4. So I'll do this over here. What fraction times what fraction gives me 1/4 where both of these denominators are identical? Well, that would be 2 times 2. So I know that this jump was a half and this jump was a half. And then 1/2 times 1/2 would give me 1/4. So at 0, half of 12 is 6. Half of 6 is 3. So that works out perfectly. Now I could fill this in here if I wanted to. Half of 3 is 3/2. And then I'm going to continue multiplying by a half. So my denominator is going to continue to be multiplied by 2. So the reason I made this new table is because I needed my y-intercept so that I could write this function more easily than if I had any other point. So I'm going to do 6 times 1/2 to the power of x. Again, remember, this is my output value that goes for my y-intercept, which is why I have x to the power, or excuse me, just to the power of x, and not x minus 1 or x minus 2 or anything like that. So that covers a graph and a table. Now with words, this is where some flashcards might be beneficial because we have some formulas that we're going to need to memorize. So if you see in your word problem some type of indication that our data or our information is growing by a percentage, we're going to use this formula here. So y is my final amount. A is my initial value or my starting value. R is the rate that we are growing, but the caveat is this needs to be as a decimal. And then X will be my total time. T is the time for one growth to happen, and that is a fraction in the exponent. Yes, the formula looks weird. It will not be so painful when we actually start to apply them. So here is an example of what it could look like if we had a growth by a percentage. The inaugural attendance of an annual music festival is 150,000. This word means that it was the first annual music festival. So the attendance Y increases by 8% each year. That's an important piece of information I need. This 150,000 is another important piece of information that I need. And I need to know that it's happening each year. Write an exponential function that represents the attendance after X years. So I need to know A, I need to know R, I need to know X, and I need to know T. A is my initial value. That's the 150,000 people. R, that's the 8% that we're going up each year. But it needs to be as a decimal. So I need to move the decimal place from where it is, which it's right here currently. It's 8.0. 2 spaces to the left. So that will be 0.08. X is the thing that we don't know. And T is how often this 8% happens. Well, it says it happens every year, so T is just 1. So that would be Y equals my initial amount, 150,000, times 1 plus R as a decimal, so 0.08. Can get myself enough room. And then X technically divided by 1. We don't have to write divided by 1. Now, in most word problems, if they're asking you to select the correct answer from a multiple choice statement, most of the time they're going to combine those. So you should see y equals 150,000 times 1.08 to the power of x. Now, since this number here is greater than 1, I know that this is a growth function. Because remember, if my ratio is greater than 1, my numbers, my output values are going up. So that is growth. Similarly, if it's decay by a percent, we're going to see, instead of 1 plus r, we're going to see 1 minus r, because we are going down a certain percentage. Oop, this isn't supposed to say decay rate. So the decay rate as a decimal. So almost the exact same equation, it's just minus instead of plus. And this is decay rate, not growth rate. All right, so Janina's taking 40 milligrams of a medication. That is my A value. The amount of medicine in her body decreases. That tells me it's decay by 15% each hour. So R is going to deal with the 15%. And T, since it says each hour, is going to be 1. X is the thing I don't know. It's asking me to write this equation for X hours. And I do need to rewrite this as a decimal. Moving the decimal place twice to the left gives me 0.15. Since this says decrease by a percent, I'm going to say y equals 40 times 1 minus 0.15 to the power of x, technically divided by 1, even though we know that's not going to end up making it to our final equation. So this would be 40 times. Now, if I actually do that subtraction, this would be 0.85 to the power of x. Again, this number is smaller than 1. I know if my ratio is smaller than 1, it will cause my output values to go down. And lastly, if it's not a percentage, this is what our equation is going to look like. So if it says double or half or triple or quadruple or quarter, that is going to be this equation here. You'll notice there is no R. It's not 1 plus. It's not 1 minus. It is just my B value. This looks a lot like the equation that we use to write the graph and the table function. So this could also be your decay rate if it says a third or a half or a quarter. That's decay. Either one. So our example for this one, a bacteria culture, we have it's quadrupling every 3 minutes. This culture is beginning with 5 bacterium, and I want to write an equation that models for x minutes. So My beginning is 5 bacterium, so A is 5. My growth is quadruple. The number that represents quadruple is 4. And then my t-value now, it's quadrupling every 3 minutes. So we're no longer dealing with a t-value of 1. I have a t-value of 3. So my equation is going to be 5 times 4 to the exponent of x divided by 3.